So today's lesson is going to be kind of nice, but kind of not. Alright, so what's nice is that it's pretty straightforward. There's not a whole lot of complicated things rocking in it, in my opinion. The bad thing is that this is yet another trig identity that I need you guys to memorize. Actually, there are two of them. Alright, and these are actually, I mean, of course I got my own corny way to help you guys remember this, but you do need to remember them. They are going to be fair game for your formula quizzes starting next week. I cannot remember if they are on the reference sheet for your exam. I will have to check that out. So what we're going to talk about today are angle, sum, / difference, identities, part 1. Alright, and so for today's, we are going to talk about cosine. Okay, so today we're going to talk about cosine. Another video we're going to talk about sine. Another video we're going to talk about tangent. We don't need to have identities for secant, cosecant, cotangent, because those are just the reciprocal of these identities that we have right here. Okay? So, first, let's do the angle sum. Sum means add. Alright, so what I mean is, what if I'm taking the cosine of some angle plus another angle? Okay, so if I'm doing the sum, the cosine of angle A plus angle B. Alright, now be careful, this is not cosine times A plus B. You don't just distribute this cosine. Alright? And this is actually going to be equal to cosine A times cosine B minus sine A times sine B. This is the wonderful formula that you need to memorize for the sum of the cosines. When we do the difference of the cosines, that means we're doing the cosine of A minus B. That is going to be cosine A cosine B plus sine A sine B. Okay, so these are the two new identities that we need to have memorized. Boom, 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 boom. Okay, and now here is going to be my silly way for you to remember this, and you're going to remember it forever because I remember when my high school teacher did this to help me remember this. Alright? The important part is that since this is cosine, we're going to start with sine. Alright? So the identities for cosine, you could remember for cosine, it needs to go cosine, cosine, sine, sine, sine. Alright? So if I have cosine A plus B, for cosine, it's cosine, cosine. So the cosine of A times the cosine of B. Sine, alright, since it was addition in the original, now it's subtraction, so I change the sign, and then I have sine of A sine B. So the cosine of A plus B is cosine, cosine, sine, sine, sine. Alright, cosine, cosine, you change the sign, and then you have sine and sine. The same thing happens down for the second one. Except now, since we're starting off negative, alright, hold on, I'm supposed to change colors. Boop, there we go. Alright, since we're starting negative, why is that doing that? Whatever. Alright, since it's starting negative, cosine A minus B, we're still going to do cosine, cosine, change the sign. It was a minus, now it's a plus, sine, sine. So it's still cosine, cosine, sine, sine, sine. Alright? So next time you guys have a formula quiz and I ask you the sum or difference identity for cosine, you should all be going cosine, cosine, sine, sine, sine. Alrighty? Now let's actually do some questions with this. Boop. Numero uno. If the sine of A is equal to 3/5, and angle A, we'll say, is in quadrant 2. Alright, that means A is an element of quadrant 2. And the cosine of B is equal to 5/13. And we'll say that B is an element of quadrant 1. Let's find the cosine of A minus B. Okay? So they're telling me the sine of A, they're telling me where it is, they're telling me the cosine of B, they're telling me where that angle is. I'm going to use, in this case, my angle difference identity for cosine. Alright? So, let's go to work. To find the cosine of A minus B, we know from the previous page that have all those identities on it, I know that the cosine of A minus B is going to be cosine, cosine, sine, sine, sine. Alright, cosine, cosine, sine, sine, sine. And then it's nice because in the actual problem they told me that the sine of A was equal to 3/5, so I'll plug that in. They also told me that the cosine of E was 5/13, so I can plug that in. This plus sign is just a plus sign, but I still need to plug in for the cosine of A and the sine of B. Well, how am I going to figure those out? The other identities that we've been using. Alright, I know that sine A is equal to 3/5. I also know that sine squared A plus cosine squared A is equal to 1. Alright, that's like our basic Pythagorean identity. So let's plug in. For sine of A, this is really 3/5 squared plus cosine squared A is equal to 1. So I get 9/25 plus cosine squared A equals 1. This gives me cosine squared A is equal to 16/25. Take the square root, cosine A is equal to plus or minus 4/5. But remember, A is in quadrant 2, and in quadrant 2, my cosines are negative. So really, I want that cosine A is equal to negative 4/5. So that's what I'm going to plug over here for cosine A. Boom. We're going to do the same thing to find the sine of B, because they gave me the cosine of B, so I can use my Pythagorean identity again, this time with B's instead of A's. Alright, and I will do that. I'll extend my happy math land. So I've got sine squared B plus cosine squared B is equal to 1. And they told me that cosine B was 5/13. Okay. So that means I've got 5/13 squared. And that's plus sine squared B. Beautiful. When you work that out, you're going to get that sine squared B plus, and then this is going to be 25/169 is equal to 1. So I get sine squared B is equal to 144/169. Or sine B, when you take the square root, is equal to plus or minus 12/13. But they told me that B was in quadrant 1, and in quadrant 1, my signs are positive, so I don't care about the negative. Sine B is equal to positive 12 over 13. So that is what I'm going to plug in up here. And now we can go ahead and multiply. This is going to give me negative 20 over 5 times 13. That gives me 65. Plus 12 times 3, that should give me 36 over 65. The nice thing here is that these have common denominators already. So then this is really negative 20 plus 36. That gives me 16 over 65. Boom, baby, done. Notice, and you guys don't have to write this, but I'm going to do this down here in this corner. When I did all this, and all this is completely correct, I got 16 over 65. If you just distributed this cosine, which you cannot do, but a lot of people want to do, alright, if you say that the cosine of A minus B is equal to the cosine of A minus the cosine of B, which it's not, alright, but that means that you'll be doing negative 4/5 minus 5 over 13. You definitely do not have common denominators here. So let's see. So after you get common denominators, you're going to get negative 52 minus alright, and then I end up getting negative 82 over 65. Are those the same things? Definitely not. Okay, so remember, when you do the cosine of A minus B, you're taking A minus B and you're plugging it into the cosine function. Alright, the cosine is not something that you can just distribute. So this is a big no. Cosine is not something that you can just distribute. And that's it, we're good. So now, see I'm doing on time, perfect. Let's do a neuter. Alright, example 2. It's going to be kind of similar to the first example. If the sine of A is equal to 3/5, and A is in quadrant 1, and cosine of B is negative 5/13, and B is in quadrant 2, find cosine of A plus B. Okay, cosine A plus B, we're still going to write our angle sum, in this case our angle sum identity. So the angle sum, cosine A plus B, is cosine, cosine, sine, sine, sine. Alright, gotta change the sign in the middle. And then let's fill in what we know. They told me that the sine of A is equal to 3/5. They told me that the cosine of B is negative 5 over 13. This minus sign will stay a minus sign. And we're going to go back, use our Pythagorean identities to find the cosine of A and the sine of B. So let's see, I've got sine squared A plus cosine squared A is equal to 1. I know that sine squared A is 3/5 squared. And you guys really should show all this work, alright? We talked about this, showing the most work possible so you can get partial credit, just in case you make an algebra error. Not that you guys would make any of those. Alright, so I get that the cosine of A is equal to positive or negative 4/5, But since I'm in quadrant 1, it is going to be positive because my x's are positive in quadrant 1. So that's going to go right here. Now let's work with the b's. I will extend my page a little bit. And I'm plugging in for the cosine of b. So this is sine squared b plus negative 5 over 13 squared. So I get that sine squared b is 144 over 169. Like I said, very similar to the last one, but we're doing a different identity. Now in this case, when I get plus or minus 12 over 13, what quadrant am I in? I'm in quadrant 2, and in quadrant 2, my signs are positive, so I want the positive. So I'll plug in here. And now, let's see, we're going to get negative 20 over 65 minus 36 over 65. So notice not the same thing as last time. And when I simplify this, they already have common denominators. I'm going to get negative 56 over 65. And that is your answer. All right, so not the same thing. But kind of the same gist. You need to know the identities. You need to know where to plug in. You need to know how to find what you need to plug in. And it really just comes with practice. Now we can also... All right, we're going to do one more Unos example. Ooh, where'd it go? There we go. Because this other new thing that we've been doing lately is proving trig identities, right? So, and now that we have these angle sum and angle difference identities, or at least for cosine we do, this is another tool that we can use to prove these trig identity questions. All right, so let's think about, or let's try and prove the cosine of pi plus x, and let's prove that that is equal to negative cosine x. Okay? Now, same approach. We're looking for the more complicated side. The left side is definitely the more complicated side. Okay? So, now we can expand that complicated side using what we just learned. Okay, so that is going to give me cosine pi cosine x minus sine pi sine x. And that is going to be equal to negative cosine x. I did nothing on the right-hand side. Now, some of you might be thinking, Ms. Adams, what did you do? You just took that left side and you made it way bigger and way more complicated than it needed to be. Wrong. Okay? It looks complicated, but remember, cosine pi, sine pi, pi is the same thing as 180 degrees. So we actually have an exact value for the cosine of pi and the sine of pi. And if we need to, we can draw a little unit circle over here as a reference. This is why I said that unit circle is important. Okay, because if I look at this picture, over here I'm at 0 degrees. Up here I'm at 90 degrees, which is the same thing as pi over 2. Over here I'm at 180 degrees, which is the same thing as pi. Down here I'm at 270, that's the same thing as 3 pi over 2. If I went all the way around, that would be 2 pi. Okay, but look right here, cosine of pi. On the unit circle, what is the x value? Because cosines are x's. what is the x value when I'm over here at pi? Well, that's -1. So instead of writing cosine pi, I can write -1. The same thing is true for the sine of pi. If I'm over here at pi, what's my y coordinate? Because remember, sines are y's. Well, my y coordinate here is 0. Let's fill in all this other stuff. Still haven't even touched the right-hand side of this. Okay? Now, -1 times cosine x, you can leave it like that, or you can just say that that's negative cosine x, minus, and then this is where we all get really happy, because 0 times anything is 0. So this goes away, because anything times 0 is 0. And then I'm just left with the right side, which is negative cosine x. Boom, baby. Those things are the exact same, so we are happy. Because I'm happy. Okay. So now we can do more trig identities. I know, your favorite thing. But now we can do more trig identities using these angle sum or difference formulas. Okay? I'm going to leave you guys with a question. All right, something to think about that we'll talk about next time. How could we use these angle sum and angle difference identities along with those special triangles that we've been talking about to come up with the cosine of 42 degrees without a calculator? All right, I'm pulling away the calculator. All right, so how can we use our angle sum and difference identity that we just learned and those special right triangles to find the cosine of 42 without, that's the biggie, without a calculator? Okay, think about that. We'll talk about that in class tomorrow. Don't forget, you do have a post-video quiz. All right, see you guys.